Again, welcome to Mathematics 164 Pre-Calculus. These lectures cover real numbers. So first, we will start with what is a real number. So in this section, we use a set of real numbers as the universal set. So we can represent the real numbers along the line called the real number line. So again, this number line will be a picture or a graph of the real numbers. Each point on the line corresponds to exactly one real number. And also each real number can be located at exactly one point on the real number. And so again, this is our line. And we can see the natural numbers. And as we said earlier, natural numbers are values that start from 1 to infinity. Then we have integers. Integer values can include 0 and negative values. So we see again natural numbers from 1. Infinity numbers can be any number to the end. So from 1 to infinity. Now with the integers, we start from negative infinity to positive infinity. Then a rational number will be all numbers that can be written as the ratio of two integers. Example, A by B. B shouldn't be 0 because any value divided by 0, there's no solution. Then also we have irrational numbers. Those will be numbers that cannot be written as a ratio of two integers. So example is given on the line here. Irrational numbers have a decimal representations that neither terminate nor repeat. Then we have real numbers. That's a set containing all the rational numbers and also the irrational numbers. So that will be an entire line. So what are the properties of a real numbers? Here we say that the following properties of a real numbers are fundamental to the study of algebra. So let's assume A, B, and C can be any real numbers. The first property will be the commutative properties. Again, commutative properties means A plus B is the same as B plus A, or A times B is the same as B times A. So example, 2 plus 3 is the same as 3 plus 2, or 2 times 3 is the same as 3 times 2. So the position of the value doesn't matter if we are doing addition and also multiplication. Now, associative property said for the addition and multiplication, if I have A plus B in the parenthesis plus C, is the same as A plus B and C in the parenthesis. The same thing applies to multiplication. A times B in the parenthesis times C is the same as B times C in the parenthesis times A. Then we have the additive identity. Additive identity is 0. So example, 1A plus 0 is the same as 0 plus A, and then the answer will be A. Now with multiplicative, it will be 1 because 1 times any number is the same number. So with 0, we do additive because 10 plus 0 or 0 plus 10 is the same as 10. 10 times 1 or 1 times 10 is the same as 10. So with multiplicative identity is 1 and additive identity is 0. Also, we say each real number A has an additive inverse, which will be denoted as negative A. So for example, A plus negative A, the answer will be 0. And then also we should know that there's a difference between negative number and the negative of a number. So for example, negative 5 is negative 5, but its negative will be positive because it will be negative 5. Also, multiplicative inverse of a non-zero real number, A, is the reciprocal of that number. So for example, A times A to the power negative 1 is the same as A to the power negative 1 times A. And A to the power negative 1 is 1 over A. So again, if you have a negative exponent, then it will be the reciprocal of that value, positive exponent. So let's say a to the power -2, the answer will be 1 divided by a to the power +2. Also, the distributive law, if I have a, then b plus c, we can distribute a to b and c. So it will be a times b, which will be ab, then a times c, which will be ac. So the answer will be ab plus ac. Now, next, let's look at inequalities and intervals. So we say inequalities will be, for example, less than, greater than or equal, or less than equal. So we say that a is less than b, then we write it in this form, a is less than b. That is, if the point representing a is to the left of the point representing b on the real number. So on the left, it will be less than the values to the right. So for example, a less than b, because what, 4 is to the left of 7 on the real number line. Also, we may say that if 7 is greater than 4, which will be written as 7 greater than 4, which means 7 is to the right, 4 is to the left. We also have s is less than or equal to y, which means s value can be, for example, 4 is less than or equal to 4. At least it's equal to 4. Or 4 less than or equal to 2 is true also, because 4 is less than 2. Now, the subset of the real numbers consisting of a real numbers x that lie between a and b, excluding a and b, we may use a regular parenthesis for that. So that's what we call the open interval. So I'm looking for values between a and b, but excluding a and b, then it will be open interval. So we can say s is greater than a or less than b, which means excluding a and b, open interval. We're also going to have a closed interval, means x is less than or equal to b, greater than or equal to a, which means the interval values from a to b, including a and b, and we call that a closed interval. Sometimes we may have half open interval, like example here, which means x is greater than a, but it's less than or equal to b. So it's close to b, but open to a. So we normally use the term half open interval. And these are some of the few examples. Open interval, s greater than a, the symbol is given. S less than b, which means it will go from a negative infinity to b, excluding the b. Or x is less than b and greater than a, which means from a to b, excluding a and b. Open interval, and then we have closed interval. So closed interval will be the dot, no hole in the dot. Open interval, there's a hole in the dot. So for example, closed interval, we have s is less than or equal to b or greater than or equal to a. So we can see that both dots are closed. Now b is close because the dot, which means s is less than or equal to b, but greater than a, so a is open. So that's again notation we use plus the graph. Next, we go to absolute value. We know from high school that absolute value is always a positive answer. So if I have an absolute value of a, the answer will be a. Now, absolute value of -2, the answer will be +2. Absolute value of +2, the answer will still be +2. So here we say sometimes we are interested in the distance a number is from origin 0 of the real number line without regard to direction. So the distance a number a is from 0 to the number line is called the absolute value of a. So the absolute value of any non-zero number is always positive. And absolute value of 0 also is 0. So for example, we say we should evaluate the following. Absolute value of -4. So the answer will be +4. Now, absolute value of +2, the answer will be +2. Then absolute value of 0, the answer will be 0. Here we have to be careful. Absolute value of -5 minus then -3. So we need to be careful here. We remove the absolute here, so we get -5 minus 3. So that will give us -8. And the answer, absolute value of a negative value is positive. So the answer will be 8. So that's the rule here. Absolute value A, if A is greater than or equal to 0. Negative A if A is less than 0. But absolute value of negative A will give us positive A also. So here we say in performing computation with real numbers, it is very important to remember the rules for computations. So here we'll do some operations with real and sign numbers. So always to add two real numbers with the same sign, again, add their absolute value and then affix their common sign. So for example, we start with the +5 plus +5. I will add 5 and 5, 5 and 6. That will give me 11. Then I'll keep the sign positive. Now, if I have -1/6 plus -2/6, I'm going to combine the two first. So -1/6 and -2/6 will give me -3/6. I had the two values and I keep the sign negative. And -3/6, I reduce it to give me half. Now, the next section said to add two real numbers with unlike, again, this time the signs are not the same. Here, the first example we have, they say when the signs are the same, combine the two numbers and keep the sign. So even if I have -4 plus -2, negative, so I'll add a number to give -2, -4 will give me -6. Then I'll keep the negative sign. Now, they said that if the signs are not the same, we need to find the difference of the absolute values. Then we keep the sign with the larger value. So example here, -4 plus 3. The difference of 4 and 3 will be 1. And since 4 is bigger than 3, we are going to keep the sign of 4, which will be -1. Here we have +5 plus -3. The signs are opposite, so 5 minus 3 is 2. Now, since 5 is greater than 3, I'll keep the sign of 5, so it will be +2. Now, next is said to subtract one real number from another. Change the sign of the number being subtracted and proceed as an addition. So, for example, -9 minus -8. I change the sign. Since this is -8, it will be plus. So I'll get -9 plus 8, which will give me -1. Now 16 minus 8, I'll use 16 plus -8, and that'll give me +8. Now, if you are doing the product of real numbers, we know negative times negative will be positive. Positive times positive is positive. Then positive times negative is negative, and negative times positive also is negative. So if we know this, we can do this multiplication. Negative times negative is positive. 3 times 4 is 12. So here they say the product of two real numbers with like signs is positive. Why they say the like signs? Because negative is positive. Positive stay positive. But if the product of real numbers have different sign, then the answer is automatically negative. So for example, 5 times -3 will give me -15. Or -3 times +4 will give me -12. But if the sign are the same, -3 times -3, then I'll get positive answer. So here we say when two or more operations with real numbers are indicated in an evaluation, it's very important that everyone agree on the order in which the operations are performed so that a unique result is guaranteed. Again, this will take us back to arithmetic operations, the order of operation. Always we perform parentheses first. Then after parentheses, we perform exponent. After exponent, we perform multiplication and division from left to right. Then the last will be addition and subtraction from left to right. So this is the order of operations in arithmetic operations. If I have any arithmetic expression and I need to find the answer, if there's a parenthesis, I'll perform it first. Next, if there's exponent, I'll perform that next. Then if I have a multiplication division, I'll start from left to right, multiplication division. Then if I have addition, subtraction, also the same thing, I'll start from left to right and do it last. So that will be the conclusion of these lectures. So again, wish everybody the best and thank you.